So I graded your organic chemistry assessment and you got Welcome to Study with Us, where I help one lucky student succeed in their science class. This semester, I'm guiding Ari, a pre-dental student, through organic chemistry. Last week, I gave Ari an assessment exam to see how much she really remembered from general chemistry. And today, we're going over what she got wrong and review the correct answers. So I graded your organic chemistry assessment to see how much you actually remember from Gen Chem, and you got a D.
Okay. I had a feeling.
Okay. But the good thing is, this isn't anything affecting your actual grade.
Okay.
This is really just seeing what do we need to review.
Right.
If you haven't taken the assessment yet, click the link in the description to download all the resources I have made so far and take the assessment. How do you feel that you got a D?
Okay, I'm going to be honest with you. Gen Chem 1, Gen Chem 2 were the hardest classes I've taken
Really?
in my undergrad. I struggled so hard. And I think in Gen Chem 1, everyone in that class struggled. So I felt like, okay, Gen Chem 2, I was like doing pretty good the entire class. And I ended up getting the same grade that I got in Gen Chem 1. So all because of the final. So it was just like really, I just felt really defeated. Like it was so discouraging. So I knew when we were going to do the reviews, it was just like low-key PTSD. I was like, oh no, these are things that like I really struggled with and concepts that I kind of got by with, but like never really got down. So I think that's why I've been so scared for OChem, because I'm like, or is it going to come back? And you know, like, is this going to, like, if I'm not ready with that, then I'm going to be like behind on this. So
What did you get in Gen Chem?
A C, actually. Yeah, I got
Both
a C.
of them? Okay.
Both of them. So anything less, I would have had to take it again. So that was how close I was. Like, I almost didn't make it. So.
Yeah. It's a C minus, correct, that you would have to retake it. Why don't we start with the first question?
Okay.
This is going back to the electron configuration.
Right.
So I'm going to actually pull the periodic table that you had.
Okay.
And I noticed that you did have the correct blocks.
I remember that, but then I was like, oh no, what were the other things I needed?
And I mean, it was good that you remembered this part. The fact that you remembered that this was S, this is D, this is P, and this was F is fantastic.
I'm glad.
The awesome news is that for organic chemistry, we don't care about D or F.
Really?
Yes, we only care about S and P.
Okay.
So that makes it so much easier.
Really nice, yeah.
So looking at this first one, the main thing that I noticed you did was you accidentally reversed S and P. That's it.
Oh.
That's the only thing that happened.
So even though I wrote it, I didn't get it.
Yes. Could have been nerves,
Silly
could have been something.
Yeah.
But let's do this together now. So I am going to have you, let's just start off with writing oxygen.
Okay.
And then doing this together, oxygen we know is here.
Right.
So then we'll start off with 1. This is still 1S. We counted 1, 2.
Right.
So that's 1S2. And you accidentally put 1P2.
Oh.
That was it. That was really the main thing.
1S2. That makes sense.
Then from there, we kind of go all the way around to the second row. Now we're at what?
2.
2S?
2.
Exactly.
Right? Okay.
Yes.
Okay, I'm remembering.
Yep.
It's coming back.
Then we'll go straight across. We're going to count all the way to oxygen. We're now in the P block,
Right.
but still in the second row.
All right, so it's 2P4?
Yes.
Okay.
Perfect.
Love
That's it.
Okay, nice.
That's it. We do not have to do anything crazy here. Again, we don't have to focus on the D block, on the F block.
Right.
It's just S and P. Now that we added an ion, specifically an anion, remember this is a negative charge.
Right.
This is going to what? Add or subtract to the last? What do you
Add to the last.
Perfect. It's the opposite. So it's literally going to be the exact same thing except just adding to the last one.
Okay. So then there'll be 1, 2.
Mhm. Perfect.
Nice.
And then something else to note is that if, let's say this was 2 minus, right? We would still continue to add here because if we remember, P has how many?
Oh, 6.
6.
Right.
Yes.
Oh, yeah.
And it only goes up to 6.
Uh-huh.
And then S only goes up to 2.
Right. Oh, yeah. I remember that.
Plus this also kind of gives you that hint here since we only have, exactly, it stops, it only goes to 6.
Okay, that makes sense.
All right, so on your own, go ahead and do
All right.
nitrogen. Good. Perfect.
Right?
That's it.
Okay.
Now that we have a +1, so a cation, what happens?
We take away.
Yes, we take away.
Like that.
Exactly. That's
Nice.
it. So now that that's correct, awesome. Again, it was just the fact that this was S, this is also S. It doesn't go, PS or
yeah.
SP,
Mm-hmm.
at least with the 1. So that's really the main concept here. Perfect.
Love it.
Nothing crazy. Let's move on to the other one that you got wrong, which was 4. And
I knew it when I was like, this does not look great.
but you did really good with the Lewis structures.
I love Lewis structures. I think they're kind of fun.
That is not a common opinion. But that's going to really help you with organic chemistry.
Okay, good. That's a little nerdy of me, but I think they're kind of cool. Okay.
It's great.
Nice.
You're basically drawing, which is cute.
I know, that's what I was like, oh, it is cute. Yeah, exactly.
But with this one, the main difference is that this is not covalent bonding. So covalent bonding, if we remember, is sharing electrons.
Right.
So you do put a bond between every single atom. But with ionic bonding, you don't.
Oh my gosh.
So this is ionic bonding because if we remember, sodium, which we have here,
Right.
these are our metals, right? Our metals, our nonmetals, these are also more metals.
Right.
But just looking at this, the metal, all of these are nonmetals, making it ionic bonding.
Oh, yeah.
So the main thing that we're going to do, you had this portion correct,
Okay.
where you connected oxygen, carbon, hydrogens all together. So why don't we draw that again?
Okay.
Yes, of
I was
course.
like, I'm trying to look at like electronegative group. Okay, and then it goes.
Going back to the valence electrons.
Is that right?
Yeah, you're
Okay.
good.
And then it was
Yep,
like that, right?
exactly. And we're going to stop there.
Okay.
So that was correct. Now, I know that this is basically all grouped together. And this is going to be another hint when we go over more organic chemistry looking structures.
Okay.
But the fact that this is a CH3 and this is all grouped together, I already know that these hydrogens are going to belong to that carbon.
Right, yeah.
So this is already telling you how to draw it in a sense. Now the next part is going to be, okay, lone pairs. Where do they go?
Yeah.
And it's remembering that oxygen has how many valence electrons?
6, right?
6.
Okay.
So we currently have how many?
2?
Yes.
Okay.
And then basically just kind of filling in any lone pairs. So where do you think that would be?
So I go 2. Wait, so be like that?
So,
Or-
and actually, let's go back to this. This is sharing an electron. So there's really 1 here.
Oh, so it'll be 1. Okay. So 1, 2, 3, 4, 5. So did I draw another dot?
You should, yes.
Oh, okay. That makes sense.
Yes. And then we're going to go over later on in another study session, we are going to go over different bonding patterns, specifically seeing how whenever this is single bonded, oxygen or halogen is going to have 3 lone pairs.
Okay.
Whenever it's double bonded, we remove a lone pair,
Okay.
and it's only going to have 2 lone pairs.
Mm-hmm.
And then eventually we'll get to triple bonds and all of that fun stuff. But I know. Then from here, the next step is to place the actual charges. So for ionic bonding, we do want to show the charges. So let's put that this would have been a -1 formal charge, and we will go over formal charges again.
Okay, so are you talking about like the bracket and that? Or?
No, so that goes back to resonance structures.
Oh, okay.
So really just put a minus sign.
Just next to, okay, I see what you're saying.
Exactly. So then now, what we're going to do, we're not going to bond the sodium. Instead, let's just write Na and a plus charge, since that's what it has.
Oh, yeah. Okay.
And that's it. This is how we would draw an ionic bond.
Okay. I don't remember this. Okay, that's good to know. Good review.
Yes. And that's it. That's all the structure would look like. We
Really?
would not bond this together. That's it.
Okay. Awesome. Nice.
Let's move on to the next one. This is resonance structures.
Okay.
So this is where you're thinking with the brackets
Okay.
to go with the overall charge.
Mhm.
Now, for this, let's play around with some structures.
Let's do it. Do we want... And then...
Perfect. And then now from here, let's go back to valence electrons. And you're going to learn quickly that you don't have to necessarily count every single time.
Mm-hmm.
You'll eventually see that, okay, I know carbon wants to have 4 bonds.
Right.
So it wants to have a full octet since it obeys the octet rule.
Mm-hmm.
And then it's the same sort of concept now going with oxygen, is that if we single bonded it, how many lone pairs will it have?
2. Or I guess 1. 2 electrons.
Well, let's put it then. So let's go ahead and start putting bonds using this.
Using this guy? So I'll go...
Cool. So far, we know that this isn't enough because carbon only has 3 bonds.
Right.
So what can we do to make carbon happy?
We could do a double bond
Yes.
on one of them.
Yes.
So we go this little guy. Just kidding. This little guy. Like that.
Perfect. Now that we have that double bond, let's fill in with our lone pairs using these.
Okay, so then it'd be
Good. You're good.
and this one would just be 1, right?
So
is there
let's recount. So looking at this, this has 1, 2, 3, 4. So there's
Oh,
2
yeah.
electrons here, right? There's
Uh-huh.
2 more there. We need
5,
another one.
6. Okay, that makes sense. This little guy.
Exactly. So whenever we have one single bond to an oxygen, there's going to be 3 lone pairs. When it's a double bond, there's going to be 2 lone pairs.
Okay, that makes sense. So triple bond to 1 lone pair. If
Yes.
we ever do one.
If
Okay.
you ever do one,
Okay.
yes, correct.
That makes sense.
Now for this, couldn't we just keep moving the double bond over and over and over, and that would be a different structure?
Yes.
Yes.
Okay.
So let's go back real quick to what a resonance structure even is.
Okay.
So a resonance structure is a different way that we can draw this exact same sort of
Right.
molecule, and it still have a valid structure, like it still be a correct Lewis structure. So for that reason, this is one option.
Right.
And then the other thing I want us to do, if I can, is what we would do is we want to make sure to include the overall charge that's given. So that's where we place the brackets on both sides. And I'm going to just put a 2 minus.
Right. Okay.
And from here, if you're not sure, maybe you forget how to do formal charges, let's go over that as well.
That'd be good.
But remember our overall formula.
Yes. Okay, I do. Yes.
Yes. So we'll specifically do it for this one, looking at the valence electrons of each atom.
Okay.
So I'm going to do the formal charge of this oxygen. The valence electrons of just typically oxygen is what?
6.
6. Okay, great. So I know that's 6 minus the bonding electrons. So by bonding electrons, I'm just looking at the electrons within the bonds that are directly touching whatever formal charge I'm looking at.
Yeah.
So that's what I mean by there's just 2.
Okay.
So, okay, great. We have 4 minus 2, 2 plus individual lone pairs. So we're actually counting each one of these.
Oh, so before.
So before, right.
Okay.
So, okay, great. I have, we said 6,
Uh-huh.
and let me actually write that out, just for this one at least. This one was 6 minus the 2 bonding electrons plus the 4. That gives us 0.
0. So no charge on that one.
No charge on this one. Yet this one, and I do want to go back to, it might seem confusing for some if you're thinking, well, oxygen only has 6 valence electrons. That's true. Yet here we have 1, 2, 3, 4, 5, 6, 7. Right? And that's where we were confused with the dot.
Right.
But it's because the formal charge was different. It's no longer 0.
That makes sense because it's -1.
It's -1, exactly. Formal charge is -1. Same thing with this one.
So that's why you have -2 total.
That's why we add this up.
Okay.
Exactly. And then the other thing is we can keep rearranging this, and we would have a total of 3 resonance structures because we can keep moving this
Out to each one.
around, remove that,
Uh-huh.
this one goes back,
Right.
and it keeps going. This one goes back.
Yeah.
And now, of course, the formal charges would change. This would be 0, and so on.
Okay.
But that's it for resonance structures.
Okay. Yep, that, I remember this. Okay,
Yes.
this is good.
Okay. All right, and the next one. Let's clear this one out. Okay, so this was sigma and pi bonds. And I knew that, didn't remember.
I think
right?
that's what I said, isn't it?
Yes.
I don't know.
At least you were honest, though.
Oh, man.
At least you were honest. That was pretty polite instead of a no. Yeah, it was nice. But so this one's actually pretty simple. It's really just remembering what everything is.
Yes, okay.
That's
yes,
it. So I'm going to have us write this out. And what I want you to do for a sigma bond is draw this symbol, and then pi, an actual pi. So on the actual one.
Okay.
So knowing that a single bond is, for example,
Sigma.
just one. So I'll have you do that for each.
Okay.
For each single bond. Perfect. And then continuing with this, I know that double bonds consist of one sigma and one pi. So let's write that also. Awesome. And I know that you circled the lone pairs, and maybe you were like, I don't know what this is. What were you thinking when you saw the lone pairs with this?
I can't remember. I was trying to remember this, actually, but I didn't remember which one went to what. So I was like, was lone pairs one of them, or was it just bonds? And I think I was circling it to try to remember. But, yeah, but I don't think it was anything, actually.
Okay, that's fine. So, awesome. This is a clue for everybody, too. Bonds. Right?
Oh.
It tells us we're just looking at the bonds.
Yeah, that makes sense.
So now we can count it up. So let's count up how many sigma bonds we have.
Including these or not?
Yes, including those.
Those ones count. So.
Good? That's it. That's all it was. Yep.
Nice.
Yeah, it was honestly just remembering.
That was my thing. I was
Yeah.
like, okay, good.
And hybridization, same sort of concept, where we just had to remember a chart. And this goes back to electron groups, and then remembering that electron groups are bonds plus lone pairs.
Okay.
So specifically here, we don't have necessarily any lone pairs. If I were to have gone back to what we just did, and let's say I was looking at this oxygen, then I would include both of these lone pairs. So a double bond only counts as one bond when we're looking at electron groups. Same with triple bonds. So this would have just been 1, 2, and 3 electron groups, making it sp2 hybridized, just for that oxygen.
Okay.
So I just wanted to show an example with lone pairs. Now let's go back to the question. And we're going to look at every single carbon. Right, that's what it asked us to find, the hybridization for each carbon in the structure. So let's start off with just this one. And I can kind of even just cover this.
Right, okay.
I just want to look at the bonds or lone pairs, in this case just bonds, that are surrounding that atom.
So that would be 4.
That would be
right?
4, exactly. So that would then be...
sp3?
Yep.
Oh. See, I really struggled with hybridization for some reason. Okay, sp3.
And then now let's move on to this carbon. So
And
how many bonds again?
Same?
Same thing, 4 bonds. And now looking at this one, how many electron groups do we have?
That would be 3.
3, correct, because this only counts as 1. So then we know it's sp2. What about the next carbon?
Also 3.
Yes.
Oh, that's
Oh, sp2, yes. Yeah. Yeah, 3 electron groups, good. And then moving on to this carbon.
That would be 4 electron groups.
Great. I know, it's just a little table.
I
right?
know.
Just-
If I
that's
had
it.
that, yeah, that's good to remember.
What about that one? How many electron groups do we have?
That one's 2.
Great,
Right?
yeah.
And then the last one's also 2.
Mm-hmm.
Okay.
That's it. That's all they were looking for.
Dang
Perfect. And then that actually was the last one. So those are the ones that you did miss.
It. Okay.
And I know it's like, this was so easy, you
I
know?
I'm like, oh yeah, duh. I'm just kidding.
It was really just little charts and a few things to remember. So I would just say that the main thing out of all of this, the most important, is going to be Lewis structures.
Okay.
And it seems like you already have that pretty down.
Okay, good.
We will move on later on to more complex structures because organic chemistry, as you can tell, I don't know if you've seen a few pictures, you know,
Yeah.
it gets a bit intimidating looking.
Right.
But I'll be there to walk you through it, explain everything, and translate.
God, thank goodness. Oh, good.
So I would say that, and then of course there's going to be simple things like hybridization that will come back. Same with resonance, polarity. It seemed like you got that down. You got all those correct.
Okay, good.
Polarity will come back.
Good.
We will eventually have acids and bases.
Mm-hmm.
Your friend, I know.
My best friend. I love acids and bases.
But it will be completely different. So
Okay.
we're not going to have the math portion to this,
Oh.
which
That was
I'm
the
sure
part.
everybody
Yeah, that
is
was the
happy
hard part.
about. There's no ice tables.
Good.
We don't have to worry about that.
Oh, yeah.
We don't
Oh,
need a calculator for organic chemistry.
Good. No
It's beautiful.
quadratic formula.
No, not
Good.
no.
We love
Yeah,
that.
as to why they put the quadratic formula.
I know in chemistry. We also did the same thing.
Come on.
We were like, what?
Yeah, I
This
felt the
is
same
good.
way. I'm like, no. Each week, I will be letting Ari know exactly which videos to watch on Community so that she is always ahead of her class. This week, the video to watch is the General Chemistry Review for Organic Chemistry video. It not only goes over all the topics you should be familiar with from Gen Chem, but also the more complicated Lewis structures that you'll constantly see throughout organic chemistry. Now, I have made this video completely free to anyone who signs up for my email list. How are you feeling with all this?
I'm feeling better. I feel a lot more confident because last night I was actually at a wedding and my friend who'd just taken OChem 1 and 2 was asking me what classes I'm taking, and so I was telling him I'm taking OChem in the fall, and he was like, oof, good luck. And I have always heard that. Like, everyone I've ever talked to has always said that to me. So I was telling him, yeah, I'm nervous, but like I think it'll be good. And so he was telling me that he started that class with 6 of his friends, and he only finished with 3 of them. And so when he told me that, I was like, oh no, don't say that to me.
Thanks. Yeah, that doesn't make me nervous at all.
I was so anxious, but I think this is like setting me up for success. So
Yes.
I'm feeling way more confident now. So I think it'll be good.
Did they like drop their major? Like
They changed majors.
They changed their majors. Yeah.
They were out. I know.
That's actually like such a common thing. Like if it doesn't get you, honestly, with Gen Chem, OChem is the next one where I see a lot of people just change their majors. They drop the class. It's insane. Like you will probably see this that in the middle of the semester, your class just starts to get smaller and smaller. But thankfully, we're here.
You're right.
You know, this is not going to happen. You have all of the guidance here that we'll go over. You'll have all the instruction. To get all the organic chemistry resources Ari will be using to get an A this semester, sign up for my email list today.